The goal of this section is to familiarize you with the concepts of weight, mass, and gravity. First, let's talk about gravity. The weight of an object is the amount of gravitational pull exerted on the object by the Earth. Gravity is what causes objects that you hold and drop off the side of a building to fall to the ground. Gravity is also what helps keep our feet firmly planted on the ground. The acceleration of all objects near the surface of the Earth is constant if air resistance is ignored. If we ignore air resistance and we drop a bowling ball and a basketball off the same building, they will hit the ground at exactly the same time. This is due to the fact that acceleration is constant, which means that everything will move with the same acceleration. Since they both have the same initial speed of 0, they should hit the ground at exactly the same time if we ignore air resistance. Let's take a look at the formula we will be using to solve problems related to gravity. Weight is equal to an object's mass multiplied by g, where g is how fast objects accelerate in free fall, or the acceleration due to gravity. The equation circle has weight on top with mass and gravity on the bottom. Looking at the units in the English system, we see that weight is measured in pounds, mass is measured in slugs, and acceleration is measured in feet per second squared, just like our other acceleration terms. In the metric system, weight is measured in newtons, mass is measured in kilograms, and gravity is measured in meters per second squared. This is a table that you will find in your notes. It shows the value of acceleration due to gravity, or g, for several different planets and the moon. On Earth, the acceleration due to gravity is 9.80 meters per second squared, or 32.2 feet per second squared. On the moon, the acceleration due to gravity is much less. It is only 1.63 meters per second squared, or 5.35 feet per second squared. It is roughly 6 times smaller on the moon than it is on Earth. This is why astronauts appear to slowly hop around the moon's surface. They weigh a lot less. Jupiter has a much larger acceleration due to gravity, since it is a much more massive planet than the Earth. G-force is a term you may have heard before. Capital G is how many times the standard acceleration of gravity you feel. G-force is felt by test pilots, race car drivers, skiers, and even you on a roller coaster. In the next video, we will look at a few examples related to the acceleration due to gravity and weight.